Welcome to another great Cal Basic demonstration. This is part 3 for the 16F171 chip family. So today we're going to move on from where we left it yesterday. We're going to set the LEDs on this board to represent the ADC value. Exciting stuff. It's pretty fundamental that we do this. So I'm not going to go too deep into what the chip does. Done that in the first 2 videos. Let's get straight into the connectivity. Recap 5 connections. You need these connections between your PIC kit or programmer, whatever type it is. These are the basic connections. I will not be using those types of connections though, because I'm using a microchip low pin count demo board, the one on the left, and you can create your own. Go back to videos 1 and 2, and you'll see that breadboard designed by Chris Roper, a really good friend in South Africa. I do have one of these ready. I have it here. It's laid out, it's connected up, and we're ready to rock and roll with respect to what we're doing today. Let's go back to PowerPoint. So what are we going to be doing? We're focusing on analog to digital, and that is the process of converting an analog signal, such as a potentiometer, which we'll be doing, a microphone, or a light signal into a digital signal that we can use inside the program. This could also be called ADC, AD, or A2D. They're all the same things. So what we're going to do is configure the ADC on this particular chip. It's going to run a conversion. We're going to read that value. We're going to set some LEDs, and we're going to display. We're going to set some LEDs with the result, and then do it again. We have the potentiometer connected to RA0 port A.0, both the same, and it's actually called ANA 0 on this particular chip. It's connected via suitable resistors, a capacitor, and the actual potentiometer itself. We'll look at that again on the board, but you must get this type of circuit set up, and I've highlighted that in the ellipse for you. So what we're going to be doing is initializing the board. That's pretty well done for you. We're going to create a variable. We will have made our standard constants beforehand, but we are going to create a variable. We're going to read the ADC within a loop. We're going to make that process easy for you by using a function called read ADC. It gives us a value back between 0 and 255. We're going to do something with it. We're going to set the LEDs with that value, wait 100 milliseconds, and then do it again. So it looks like this in terms of a flow diagram. Initialize, create variables, read the ADC. It then, once it's read the ADC, it says if it's less than 50, do something. If it's between 2 values, do something different. And this diagram is quite useful, and I will leave this up for 3 seconds so that you can pause on that and study it. So we have example code. We can look at that and we can review the results on the physical hardware. But I'm also going to give you some other insights into GCStudio, IntelliSense I'll touch on, and the help, how we're going to change some default values, and a bit on PICInfo, the tool that we use to understand a microcontroller. And we'll just do that all within the IDE itself. With no more ado, let's get stuck into that. This is my desktop. Press Windows, GCStudio, and it gives me that as an option, and it starts up GCStudio. We are running some chip demonstrations, and they're shown in my Open Recent. So if I open those, it will flash up the G-code IDE, and that's where we left it yesterday. And that's fine. So what we're going to do is we're going to shut down the program we had yesterday, 040, and we're going to open the one we want to do today, which is 050, show A to D value on LEDs. Let's go to the top of the code, get ready to do the walkthrough, but first of all, let's get rid of that Explorer. I'm just going to hit the get the little page at the top. I could have pressed Control B. Let me zoom in for you by pressing Control plus. So we saw this yesterday. Hash chip 16F126 and option explicit. You need to state the chip, and you should always use option explicit. Some constants. Seen these before. I define a constant called LED port because that's quite useful should I want to change to a different port. So that LED port is equal to lat_c. I define a potentiometer constant on RA0. I do that because I'm going to set it to in later on. But I also set the LEDs RC0 to RC3 to out because they're digital outs. So what I've got is a set of constants I can reuse. But let's look at some programming now. So I'm going to create a variable called ADC val. I'm going to reuse that, and I'm going to put the contents of this read AD in there. I do that by creating a dim, and I want a byte value. So I say dim ADC val as a byte. There are other options in here, and I'll come on to those later. I have a loop, a do loop. Do loop, if I move to the left of the word do, there's an arrow up, and I can close it and open it. Quite useful. Then I read the AD, and I've said this before, I need a constant for that, and that's called ANA0. And if you use the wrong constant, it can be confusing. Let's take a divergence for a minute. Press. How do I know that you're going to get the right one? Because you're going to go into PICInfo. I press F4, PICInfo. I can take it from my list here, look, and up pops a tool. It's a Great Cow Basic tool, and it's got the details of chips. I can select my chip. Mine is pre-selected, 16F171xx. And you can access many different utilities and device dashboard like the data sheets, etc. from here. You can set the configuration if you want to in here, but I'm just going to want you to look at chip data tab. And in here it says ADC constants, and it says that you can use A, and then there's an option of an A with another option of a number. So there's a letter and a number. And a real usage is this. It says you can use ANA0 right the way through to ANG7. And the way to do this is look at the data sheet. So if I wanted to open up the data sheet and I look at it, I can push this button here and it will pop open the data sheet for me. And once I'm in the data sheet, just to confirm, Control F, ANO, ANA0, and it takes me directly to the entry for RA0. So I'm pretty confident I'm talking to the right port. So let's go back to GC code now. And here we go. I'm going to read this value, put it, and put the result of my ADC conversion inside of ADC val. And then I do a select case. And the structure of a select case, it starts with select case ADC val. And if I select the word, press F1, it will bring up the help. But we won't go into the details of the help, but essentially the construction is select case var, and then we have a case statement, and we're going to use a range, and then we're going to do something if it matches that condition. So back in my editor, I say if the case is 0 to 49, set no LEDs. If it's 50 to 99, set 1 LED. 100 to 149, 2 LEDs. 150 to 200, 3 LEDs. Else, set 4. But how did I know to use this, read AD? Because I can use IntelliSense, RED, and it shows me the syntax of the whole command. Look, I can get rid of that by pressing Control Space, and it will give me a little bit of help. Look. Do that again. RED. Oh, there's different options, but I want Read AD. I could click on this on the right hand side and it will complete it for me. Do it again, RED. I've got my mouse over this little bit of help, Control Space, and it brings up the full IntelliSense. You could also press F1 for help. And in here it refers to, you could use ANO or AN0 or ANA0, and that's the option that we're going to be using. So Read AD goes to blue to make sure it's a valid syntax, and that's my program. Let's press F4, F5 even, to compile the program. And we get all this stuff flash up, and we're going to come back to that in a minute. What's happening out in the lab? Let's have a look what's happening out on the, it's already programmed it, and there's no action. That looks sad, but let me put a screwdriver in the potentiometer, and as I rotate the potentiometer, one LED goes live as expected. 2 LEDs goes live, 3 LEDs from 4. And as I rotate it, I get a proportional display on the LEDs. We've done exactly what we wanted to do. We're reading an ADC value. We've converted it using the select case into a display for the 4 LEDs. So let's just look at some other things whilst we're here today inside of this editor. We can see that we're getting a lot of information provided to us by the compiler. You may want to read this. It has information about the libraries it's loaded. It has information about the chip, the frequency it has set the chip, the types of programmer it is selected, and it has said in here that I have in here, it has skipped over the Arduino one because this is not an Arduino chip. And it says I've selected PIC Plus automatically for you, which is correct because it's a PIC. It says it's set the chip model, the frequency, how much RAM it's got, and then it goes into the details of the compilation process in terms of what it's compiling, how it's loaded it into memory, and how long that took. It then says, gives you a summary. It then converts that in using something called GCStudio. So it takes the ASM source it's generated to produce the machine-specific hex file, and then it programs it. And it gives you a lot of information. You might not want all this. If you press F4 and type in preference or editor, I think they all come up with the same thing. I like using prefs. It will list out edit programmer preferences, and we're going to make a change in the settings and then just display the difference. Let me show you this. Zoom in on that for you. Once I find it. Oh, there it is there. These are all the programmers you could select. I don't want you to change those yet. We'll come back to those later in the week. Compiler. I want you to change it from verbose mode to suppress the summary mode. So verbose is what it is now. And there are 3 different levels. You can have verbose. You can turn that off or suppress. I just want suppress because it's going to give us a nice little short report now. Back into here. Press F5 or press the make hex and flash icon. And now when it does it, I get a very short display. It doesn't ramble, it's just giving you the key essence of what's actually occurring. And we can make that shorter and shorter. It basically says in here, assembling the program, and then it's gone straight into programming it. So now we've got it a bit faster. So today I wanted to show you how to use read AD, a 0 to 255 value, and display that on the LEDs as we were and as demonstrated a little while ago, but I'll just repeat that. And there we go. It's a very useful function. Back to PowerPoint. So we've done setting the sequence of LEDs with a delay today, but tomorrow we're going to use that to actually set a delay value rather than just show us the value of the ADC. So tomorrow we're going to sequence the LEDs, we're going to have them rotate automatically, and we're going to use the value that's returned from the ADC read as a delay function, so they'll go faster and quicker. How exciting. So with that, I'll call it a wrap. Great Cloud Basic.